Okay, so looking at 5.1 vertical asymptote, so this actually goes nicely with what we just did for 1.2. I talked a little bit about it, but I didn't actually go through an example with you. Again, this is based on stuff that you did in Pre-Calc 12. You've looked at 1 over x minus 1 before, and we know that any time that we have a polynomial in the denominator, we need to look at the restrictions or look to see what is not allowed. And so we know that 1 is not allowed just by looking at it, but when we look at the limit here, it's asking as x approaches 1. So it's the same problem as what we looked at last day and in 1.2 as well. So just by looking at it, does it have a limit? Like, we haven't even done anything yet, but based on our concept of what limits are and what we talked about, does it have a limit? It doesn't. So we already know that the limit does not exist, right? The thing is, it's not enough for us to just say the limit does not exist. We need to show or prove or give a reason for why that's the case. And there's different ways that we can do that. So maybe we'll just very quickly go through the different ways that we can demonstrate or show that. To start off with, we briefly looked at this in the last video, or the last section in 1.2. We could do a table of values. And we look to see what the restriction is in the denominator to help guide us with what to do in the table of values. So basically what I want to do when I'm working with this is maybe like somewhere down the middle, I'm going to put a 1 there because I know that's the thing, that's the issue or the problem in this. And I'm going to put a line there because I know at 1 it's undefined. We already talked about that. Maybe as I'm doing that, I'll also kind of sketch out what the graph looks like because they're both just methods of showing exactly the same thing. So at my x value of 1, I know that if this is what's happening here, then I must have a vertical asymptote. Vertical asymptote. Good? And we all know what that is. Review from last year. So the reason I set up my table of values this way is just like in the last example, I want to look for values to the left of the vertical asymptote and to the right of the vertical asymptote. So I just basically want to pick values as close as possible, like to approaching the asymptote, because there's usually a lot of activity that happens there. So maybe a good place for me to start is as close as I can get to here would be like, and there's no right or wrong for how you do this, but maybe I start with like 1.001. That's super close, but not quite there. 1.01 might be another one, and then 1.1 might be another one. It doesn't matter. You can pick whatever you want. I just know that I want to pick a lot of stuff that's super close and approaching the asymptote. When I do that, I'd be plugging it into here, so we can see for the first one we would get a y value of 10, then of 100, and then the next one would be 1,000. So the only reason I'm doing this is because I want to see the pattern or the trend of what is happening. So that tells me that when I go to the right of my asymptote, because these are values that are larger than my asymptote, I actually probably should have done them below, which would have made more sense, but that's okay. It's showing me that the pattern or the trend of what's happening with the y values is that they're going upwards, right? And all I was trying to do, I knew it was either going to go up or below. So I know that I must have a pattern or trend that's going like this. Do you see that we also have a horizontal asymptote at y equals 0? So right on the x-axis. How did I know that just by looking at the equation, just to build in some review? So there is a horizontal asymptote here as well. We last year in Pre-Calc 12 learned how to analyze the equation to be able to just tell by looking at it. What indicates that we have a horizontal asymptote there? Ooh, it's been a while. Basically, if I have a variable in the denominator that is larger than the variable in the numerator, like the degree of it, then I know that there's a horizontal asymptote at y equals 0. Does that make sense? So, and that, like the most basic example is if I had something like 1 over x, right away I know there must be a horizontal asymptote. If I change that to make it x over x squared, I still would have a horizontal asymptote. Does that make sense? So just some quick review for how we're coming up with that or where that's coming from. And then if I want to look on the other side of the asymptote of what's going on, I could pick values like let's say maybe something like 0.999. Then maybe I do 0.99, and then maybe I do 0.9. It doesn't matter what you pick. I'm just picking ones that I know are super close to it. And I'd have negative 1,000 this time, negative 100 this time, negative 10. Like, you don't actually physically need to do this. We kind of have past knowledge of this. I basically just wanted to pick a few values to see whether my trend would be above the x-axis or below. But I already kind of had a mental picture of what this was going to look like. Make sense so far? Okay, so then what we would get from this is, let me color coordinate it, the limit as x approaches 1 from the negative side, right, from the left of the asymptote, of f of x does not equal the limit as x approaches 1 from the positive side of f of x. Another way that I can write this, because you're going to see this language and this vocabulary, I'm going to say it here, is I could say it diverges at the point of interest. The point of interest, meaning, I'll put it in brackets here, like at x equals 1, it's diverging, meaning it's going in two totally opposite directions, which is an indication of what's happening here. Make sense? That's basically it. So just to remind you, I had put this in the other lesson, but it's page 212, and it's numbers 1 and 2A to F. That's your work.